8th comprehensive session of the LS PLC training, and I am delighted to be your instructor, Ali Kasti. In this particular lesson, we will thoroughly introduce the various and distinct types of counters that are available in LS PLC, and we will also gain a much deeper and more practical understanding of precisely how to effectively program them within the powerful XG5000 software environment. Please stay with me throughout this informative session. On to a roll cue. Alright, let's start today's lesson with an example. Here, it clearly shows us an industrial environment that is specifically related to the process of bottle filling and packaging. Here, we have meticulously utilized two distinct sensors and two separate displays. The precise way this system effectively operates is that when the individual bottles gracefully pass directly in front of our initial primary sensor, this very first display immediately and accurately increases the numerical count by exactly 1 unit. As you can see, whenever any of these bottles passes in front of the sensor, our display increases the count by 1 and actually counts the number of bottles for us. Finally, when all 4 bottles are filled, they are grouped together here as a pack. When they pass in front of our second sensor, this display serves as the primary counter for the packs, and its essential function is to accurately tally and record the number of packs as they pass by. This capability allows for precise monitoring and management of production. Now, if we intend to develop this specific program using a programmable logic controller or PLC, it is absolutely necessary to incorporate dedicated counters. These counters are fundamental components that enable us to effectively and reliably count discrete units, such as the individual bottles, ensuring accuracy in the automated process. So when we connect our industrial sensor device to the programmable logic controller, often referred to as a PLC input, and then utilize a dedicated counter function within the PLC's programming logic, it ensures that each and every time the sensor is accurately activated or triggered, our sophisticated counter mechanism can reliably and precisely increment by 1 number for us. Now, depending on the specific type of counter we choose to employ, our counter can be either incrementally increasing or it can be decrementally decreasing. Next, we will get much more familiar with the various types of counters that we can effectively utilize in LS PLCS, and at the very end of this session, we will then proceed to go into the XG5000 software application and also comprehensively learn how to program and configure these specific counters. So in LS PLCs, we have 4 types of counters: up counters, down counters, up-down counters, and ring counters are all fundamental types of digital counters. Well, in a typical industrial environment, we can effectively utilize various types of sophisticated sensors and subsequently connect each and every one of these individual sensors to the input of the LS PLC system. Each of these specific sensors can then be reliably connected to a dedicated counter unit. In our comprehensive program, whenever any of these sophisticated sensors are actively engaged and generate a distinct electrical pulse for us, that particular counter can either precisely increment or accurately decrement its value by a single unit. Now, depending entirely upon the specific type of counter we utilize, it can effectively provide us with a variety of different operational modes. Or for instance, we can logically AND 2 of these individual sensors together and seamlessly connect them to one of these versatile counters. When we logically AND 2 sensors together, it means that both of these sensors absolutely have to be in an on state. In that case, the counter will increment by 1. Alternatively, we can logically OR 2 distinct sensors together and then connect them to one of these available counters. Consequently, when either of these 2 individual sensors is actively triggered or activated, then the connected counter will reliably increment its value by precisely 1 unit. So each and every one of these individual sensors can be effectively connected to a dedicated counter within our comprehensive program environment and subsequently perform the necessary and precise counting operations for us. Well, the first counter we're going to introduce today is the up counter. Here we have an industrial environment. It shows us that we have used a sensor. We have connected the sensor to input number 2 of the LS PLC. we meticulously connected input number 1 of the programmable logic controller, or PLC, to a dedicated start push button, which we specifically configured to effectively reset our counter. Furthermore, in this comprehensive setup, we also incorporated a clear and informative display unit that we seamlessly connected to the LS PLC through the reliable RS485 serial communication port. The fundamental way this entire system operates is that whenever any of these distinct bottles are precisely placed in front of the optical sensor, a specific action is triggered. So the counter increases by 1 for us, and for example, when we press the reset button, the counter value immediately returns to 0. Therefore, this particular type of counter can have many significant and practical uses in various industries. As long as we do not press the reset button, the counter continuously keeps increasing its value. Whenever we precisely press the reset button, the entire counter value immediately goes back to a perfect 0 for us. Now, we can accurately count these individual soda bottles, and then, at a later, more convenient time, we can eventually pack them all together as a single cohesive pack. Here, we can effectively utilize another specialized sensor again, and we can also meticulously count the precise number of these completed packs using this very same sensor and the sophisticated counter mechanism that we carefully use within the program itself. Well, in the XG5000 software, specifically within the comprehensive section that is related to various functions and also function blocks, if we meticulously search for the term CTU, this particular term unequivocally refers to the up counter, which is a fundamental component in many programming applications. It brings up the counter for us, and now we want to get familiar with the different terminals of this counter. The first terminal it has is the CU terminal, which is related to our pulse. So in the program environment, here we need to use either a normally open contact or a normally closed contact and enter the address of our sensor here, so that each time the sensor is activated, a pulse is generated, and this terminal can count that pulse for us. This part is related to resetting our counter. Here, for example, we can effectively utilize a variable whose fundamental data type is Boolean, and subsequently, when that particular variable becomes true, it automatically resets our counter. This is the PV, which represents the preset value, where we can precisely enter the specific count value we have carefully considered and have in mind for this operation. Now, for example, we want our counter to count up to 10. Here we can simply enter the numerical value of 10, or alternatively, we have the option to utilize a variable within our programming environment. This variable's data type must be an integer, and we can then proceed to input our calculated count value directly into that specific variable. This particular segment is commonly referred to as CV, which is an abbreviation that precisely stands for current value, representing the immediate and present numerical state. It displays the counted value at any moment, and we can use a variable here whose data type is integer, so that every number the counter counts for us can be seen here. And finally, here is the output of our counter, where we can use a variable of Boolean type. When our current count, that is to say the present value, PV, becomes precisely equal to the comparison value, CV, the resulting output of the counter then turns to a logical one. Well, the second counter we are introducing to you is the down counter. As you can see, we have a container here with a number of balls inside it. Here we have used a sensor that we have connected to the input of our PLC. For each and every one of these individual balls that precisely passes in front of the highly sensitive sensor, our meticulously designed counter systematically decreases the total count by exactly 1. And as you can clearly and distinctly see, it is effectively and efficiently reducing the overall number of balls for us, just as intended. And finally, when our container is empty, the count becomes 0. We have also successfully connected this particular display to our LS PLC through the RS485 serial communication port. So when we meticulously search for CTD in the software, specifically under the functions and function blocks section, it directly relates to our essential down counter function. Well, this is quite similar to the previous counter with one significant difference. The CU, which is actually directly related to our pulse input, where we specifically need to accurately enter the precise address of our sensor here. Now here we definitely and absolutely need to utilize either a normally open contact or alternatively a normally closed contact, and we should meticulously enter the precise address of the input to which we've actually and physically connected that particular sensor here at this specific point in the configuration. This part is the LD terminal, which is related to loading the preset value. Here too we can use a variable of Boolean type. The difference between this counter and the previous one is that before starting, we definitely need to preset the counter once. That is to say, before the actual operation commences, the counter absolutely must be preset at least once so that the predetermined PV value is accurately placed inside the current CV. And for each and every individual pulse that is subsequently generated, the counter meticulously decreases the numerical value by precisely 1 unit. Finally, when our current CV value ultimately reaches the absolute 0 point, the output signal then becomes a definitive one. This particular functionality too is something that we can extensively and effectively utilize in various industrial applications and settings. Our next counter, which is an interesting device, is known as the up-down counter. As you can observe, it effectively displays the entrance and exit movements of vehicles within a car parking lot for us. Here, we have utilized one sensor for the entrance point and another sensor for the exit point, every car that enters the parking lot. This vehicle is detected by this sensitive sensor, which generates an electrical pulse, allowing the counter mechanism to increase the count by 1. And when vehicles exit the parking lot area, they are detected by this sensitive sensor, which also generates an electrical pulse, enabling us to decrease our current count by 1. So when we utilize an up-down counter, which is a specialized type of electronic counter, we gain the significant advantage of being able to simultaneously both increase and decrease the count. This particular capability is incredibly useful and is often considered one of its primary and most common applications, especially in scenarios such as managing the flow of vehicles at parking lot entrances, where precise and dynamic counting is essential. And finally, we can clearly see the total number of automobiles currently located inside the parking facility, prominently displayed right here on this dedicated digital display. Well, to accurately represent the functionality of the up-down counter, we specifically utilize the designation CTUD. So, as we have previously mentioned, it is indeed possible to connect two distinct sensors to this particular counter at precisely the same time. One of the primary sensors is specifically designed for the increment mode of operation. Another distinct sensor is capable of functioning effectively for the decrement mode, and subsequently we can ultimately obtain the final calculated value right here. Furthermore, in this particular setup, we also have a dedicated reset terminal available for use. When we activate the reset function, our counter value immediately becomes 0. For our counter to effectively work in decrement mode, it is absolutely essential that before the counter is fully activated, we must carefully preset it at least once using this dedicated LD terminal. Therefore, this crucial presetting operation is directly and intrinsically related to the proper functioning of the down counter mode, which is also known as the decrement mode. This ensures accurate and reliable operation throughout the entire process. If we wanted to operate in decrement mode, we must perform a preset here at least once. Here is also the PV value, meaning the counting value that the counter can perform is entered here. And here we have used two outputs as well. One of our outputs is related to the up counter, and one of our outputs is related to the down counter, and we can use each of these outputs separately. Well, here is the same industrial environment that we introduced to you at the beginning of the lesson. Here we have connected our first sensor to a ring counter The ring counter functions very much like a standard up counter, with the significant difference that when the count ultimately reaches its predetermined end, it automatically and immediately resets the value back to 1. In other words, it consistently operates in a continuous loop. Here, for instance, we have carefully set the counter to count incrementally up to the specific value of 4. Consequently, when its count precisely reaches the number 4, it then promptly starts counting from 1 all over again. Now, see, this count has reached 4. Now, when the next bottle comes, it starts the count from 1. Look, when the next bottle arrives, our counter value becomes 1. So this particular setup effectively acts as a continuous loop for us. And here in this specific configuration, we have indeed utilized an LS PLC. We connected our first sensor to one of the inputs. The second sensor was also connected in the same way to input number 31 of the PLC. Here we use 2 displays. We meticulously networked the displays together utilizing an RS485 serial port. And in this particular instance, we employed a Q0 output from the PLC and subsequently connected it directly to this specific nozzle. Consequently, when our Q0 output is actively engaged or activated, this nozzle promptly receives the necessary command and immediately commences the process of filling the bottles. So, in addition to that, here we also thoughtfully connected our second sensor to an up counter, ensuring precise measurement and control. We successfully connected our very first sensor to a ring counter. So we can effectively utilize counters in our programming, and they possess many practical applications for us in industry. Here it clearly displays the ring counter for us, which we consistently represent with CTR. This specific terminal is directly related to our incoming pulse. We typically use either a normally open or a normally closed electrical contact. Here we enter the address of the input to which the sensor is connected. Here we carefully enter the exact count value. This particular terminal is specifically for resetting. Whenever this terminal is activated, our counter resets. The CV displays the count value for us, and we can readily use a variable of the integer data type for it. We can clearly view the current count value right here, and then finally there is the Q output, which is specifically activated when the process variable, PV, precisely equals the control value, CV. Our Q becomes 1. All right, now let's enter the XG5000 software environment and get more familiar with programming these counters.